Okay, so good evening, guys. Welcome to the 8th session of Project J. I hope you all are doing fine. So I'm Amirul, and I'm going to be your lecturer for today. So if you have any question, you can just type it in the chat box. And our TAs will try his best to answer all of your questions. So without further ado, let's get started. So these are the things that we are going to learn today. First one is good program design, followed by debugging, and the last one is Java interfaces. So let's jump into it. So what is a good program? These are the characteristics of a good program. A good program will contain no errors at all. The code inside a good program is also easy to understand and also easy to modify. The program must also have a good performance in terms of the execution speed of that particular program. So in order for us to make our program easy to understand, we should be consistent when we are writing our codes. So consistent here means we are following a certain style when we are writing our codes. So in Java, we have a standard style which are widely accepted by the programmers. So one of the standard style is about naming convention. In Java, when we are naming our variables and methods, the first letter of the first word must be in lowercase letter, and the first letter of the following words must be in an uppercase letter. For example, high score, and also for methods, draw with color. But for classes, the first letter, of both the first word and the following words must be in uppercase letter. For example, web page, and also email address. So a good program also must have a good class design. So these are the guides for us that we can follow in order for us to create a good class design. The first one is we should make fields and methods private by default. We only change the private access specifier of our methods to public if we need to. And the last one, if we want to access the value of a field inside our class, we need to create a method to do so. So this is an example. If we want to access the value of bar, which is an instance variable inside our class, we need to create a method with a public access specifier to access the value of bar. This is because bar is private by default. So we cannot access the value of bar outside of the class. So by using method with a public access specifier, then we can access the value of bar. So that's all for our first topic for today, which is a good program design. Next, we are going to move on to our second topic, which is debugging. So what is debugging? Debugging is the process of finding and correcting an error in a program. So it is one of the fundamental skills in programming. So the first step on how to debug is to not introduce any errors into our program in the first place. So these are the ways which we can follow in order for us to avoid from introducing any errors into our program. So the first one, we should reuse the codes which we can reuse. Next, we should design our program before we code it. And the last one, we should always follow the best practices when we are writing our codes. Best practices is just the recommended procedures or techniques to avoid common problems. So we should design a pseudocode for our program before we code it. A pseudocode is just a high-level understandable description of what a program is supposed to do. So here we have an example of a pseudocode. Is a number within the interval x, y. So if we convert this pseudocode into a syntax-based program, it will become like this. Okay. So besides designing a pseudocode for our program, we should also design the objects that we are going to use inside our program. So here we have an example of how we can design the structure of objects that we are going to use inside our program. For example, we have an object called SimpleDraw. Then inside SimpleDraw, we have another object called drawGraphic, which is the instance variable inside SimpleDraw. While inside drawGraphic, we have three array lists of bouncy box objects, which are the instance variables inside drawGraphic. So this is how we can design the structure of the objects that we are going to use inside our program. So these are the codes for our objects design just now, this one. So inside SimpleDraw, we have an object of drawGraphics. And also inside drawGraphics, we have array list of bouncy box objects, which is the instance variables of drawGraphics. So that's all for the first step on how to debug. Next, we're going to go to the second step on how to debug. We should find the mistakes in our program earlier. So by finding the mistakes in our program earlier, then naturally it will be easier for us to debug it later on. So these are the ways which we can follow in order for us to detect or to find the mistakes inside our program earlier. The first one, we should test our pseudocode design. The tools inside our IDE also can detect the potential errors inside our program. We should also test the implementation of our codes. And the last one, we can use assertions to check our work. So the first one is about testing the implementation of our codes against the design of our pseudocode. So in order for us to do that, we should consider all the possible paths in our program. And then for each path, we use at least one example to test that path. Okay, for example, here we have a pseudocode. In this pseudocode, we are dealing with an interval. So we should consider all the possible values which number could be. And then from there, we draft all the possible paths that our program could have, whether the number is below the lower bound or it is equal to the lower bound or others. So we should consider all of these paths. This is also the same. We should consider all of this. Okay. So after we have considered all the possible paths in our program, next, we need to test all those paths. In this example here, we are going to test what if number is equal to the upper bound. So we substitute the values into the pseudocode. So we have number as 5 here, and then the interval 3, and the upper bound is 5. Number is equal to the upper bound. Okay, then we read back the pseudocode. Is 5 in the interval 3, 5? So the answer for the pseudocode is false. 5 is not in this interval, because even though 5 is the upper bound of this interval, but this parenthesis here is used to indicate that 5 is not included in this interval. So the answer or the output for this pseudocode is false. Next, we substitute all the values inside our implementation, inside our program, because we want to verify whether our implementation is the same with our pseudocode or not. So we substitute the values. If 5 is greater than 3, 5 is not lesser than 3. So this statement is false. So our program will go to the next line. If 5 is greater than 5, 5 is not greater than 5. So this statement is also false. So our program will go to the next line. In the next line, our program returns true. But just now, the output or the answer for this pseudocode is false. Since our implementation returns true, then we can know that actually our implementation here is wrong. The second statement here should be greater than equal instead of just greater than. So this is how we can detect the mistakes in our program earlier by testing our implementation against the design of our pseudocode. Okay, next. The tools inside our IDE can also provide us for a way to detect the potential errors in our program. So those tools will give out warnings. Warnings may not be a mistake, but it likely is. So the suggestion is to always fix all the warnings given out by the tools. We can also perform extra checks to our program by using the tools such as find bugs and other related tools. We can also use assertions to check our work. So we use assertions to verify whether or not our code does what we expect. So here we have a statement. Difference is greater than equal to 0. So in this statement, we assert that difference must be greater or equal to 0. So if this statement is true, nothing will happen. But if it is false, if difference is less than 0 means a negative number, then the program will crash with error. So let's take a look at the example. Difference here is time. Because we can see here, time minus fastest time, we will get time. So difference is time, and time cannot be a negative number. So in this statement, we assert that difference must be 0 or greater than 0. So if by chance our program crash, then we know that the difference right now is a negative number. So our implementation, our codes did not behave like what we expect. So from there, we can then plan our approach on how we can resolve this unexpected value. So that's all for the second step on how to debug. Next, we are going to go to the third step on how to debug. We should reproduce the error. If we encounter an error once, but later when we try to test our codes, our codes again, the error won't come up. So we need to figure out how we can repeat the error that we encounter just now. So in order for us to do that, we should go back to the working version of our program, and introduce a little changes one at a time to our program until the error comes back. And then we can eliminate all the extra stuff that we didn't use to avoid from any other bugs. Step 4 on how to debug, we should generate hypotheses. What is going wrong? What might be causing the error? So we should keep questioning ourselves. We should keep making assumptions of the possible cause for the bug or for the bug or bugs in our program. Next, step 5, we should collect information. If we suspect X is the possible bug in our program, then we should keep track the value of X every time the value of X changes. So one way of doing that is by using println method. We can use println method to print out the value of X at a certain point in our program where the value of X changes, so that we can keep track of the value of X. The sixth step, and also the last step on how to debug, we should examine our data. Is your hypothesis correct? Does your hypothesis fix the error? Does your hypothesis resolve the bug? So if it is not, then you need to generate a new hypothesis. And then from there, you need to repeat the steps in order to resolve your bugs. So that's all for the second topic for today, which is debugging. Next, we're going to move on to our last topic for today, which is Java interfaces. This one, I think you can just read it by yourself, why we use methods, why we use objects. I think you can read it by yourself. So I'm going to go straight to this one. Okay, what is interfaces? An interface is similar to an object. An interface is similar to a class, but we create an interface by using interface keyword instead of class keyword, followed by the name of the interface. Okay. Secondly, inside an interface, we cannot have any constructor. So there is no public drawable open parenthesis, close parenthesis. There is no constructor for an interface. So if we don't have any constructor for an interface, then we can conclude that we cannot create an object out of an interface. So there will be no drawable objects. So that's the second point. Thirdly, we can have methods inside our interface, but the methods do not have any implementation. It means there is no codes inside the body of the methods, because usually we have curly braces here, open curly braces, and then close curly braces. Inside that braces, we have the codes for the methods, right? But for an interface, we don't have that. We just put semicolon at the end of the line after the name of the methods and also after the parameter of the methods. So why the methods inside an interface do not have any implementation? So this is because of the purpose of the interface itself. An interface is used to define what are the methods that should have inside the class that implementing it. So that's the third point. Next, a class can implement an interface by using implements keyword. So here we have class flower implements drawable. So when a class implementing an interface, that class must have all the methods stated inside the interface. So here, if flower implements drawable, then flower must have all the methods stated inside the drawable. It means flower must have draw method and also set color method. So as you can see here, this is the purpose of an interface. It is like an instructor telling the class of what are the methods should be inside the class itself. So that's the fourth point. And lastly, a class can implement more than one interfaces. So if we have other interfaces that we want to implement, we can just put comma here, followed by the name of the interfaces. Okay. So this is just what I have mentioned just now. In an interface, we can only have methods. This is mostly true, but we can also have constants inside it. But usually we only have methods inside an interface. Second, the methods inside the interface do not have any codes, do not have any implementation, only the definition. And the last one, I also have mentioned this just now. A class can implement more than one interfaces. Just now, I have mentioned that we cannot create an object of an interfaces, right? But we can use an interface as a reference to the objects of the class that implementing it. For example, here, BouncyBox class implements drawable interface. So we can use drawable interface as a reference to the BouncyBox object. Okay. So the last one is about casting. If we initially we use the interface reference to refer to the object that of class that implementing the interface, we can actually cast the interface reference back to the class reference like this, and then we can use the class reference inside our program. Okay, so that's the end of our lecture for today. So next, we will have our tutor to demonstrate for us on how we can create and use Java interfaces. But before that, our tutor will give more examples on how we can use assert. Just now we learned about assertions to debug our program. So I will end my presentation here, and I will pass the session to the tutor. If you have any questions, you can just type it in the chat box. So with that, thank you.
Hello everyone. Can you hear me?
Yes, sure.
Okay. I'm Azhar. I'm your tutor, and I will in charge in assert. So I will present my screen. Can you see?
Yes, we can.
Okay. So I will start the first example. Okay. Okay. Right now I will have the class mark. So I will teach you how to use asset, how
Sorry,
to
Azhar,
verify. Yeah.
can you enlarge the font a bit so that we can see it clearly?
Wait. Wait. I will. Macam mana tadi? Hmm. Can you hello? Can you see clear, right?
Yes, now it's clear. Yes.
Okay.
Thank you.
I will start my session. Okay. Right now I have the class of maths. So there in the class there is a public static void main is as a main to test our program. So our mark is 20 right now. So we use how to use a set. Okay, first a set and then our expression that is more than or equals to 30. So after that we have colon, right? So after the colon we have the our sentence you need to study more hard. Okay, what is it mean? Okay, if our is as the we learned before, assert when our expression is true, so it will do nothing. So it will go to next line and print the pass. So if the mark is um, our expression is not certified or false, it will print you need to study more hard. So I will run. So as you can see, it's still pass. Even though it's false, it still print the next line. This is because our asset is not enabled yet. So how to enable it? You just to um, type the command like this. Java minus EA. It's mean enable assertion. So next, um, our name class that is mark.java, right? So mark.java. So enter it and it will come error because our expression is not certified because 20 is not more than or equal to 30. So it will print assertion in treatment. You need to study more hard. It means our expression is false. So how to disable the assertion again? So how to disable it? Java minus DA is mean disable assertion and our class name. So mark.java. So it's it will disable our assertion. So I will show you the next. So I will use the chat way. So in this chat way class, I will we need to get the input from user. So we can see more clearly. Okay, wait, I will run it. Okay, please enter your weights. Okay, our assertion expression is weight is more than or equals to 50 or 40, right? So if we put the enter 50, it will print the you are not underweight because our expression is right. So if our wait, if I put the input is less than or equal to 40, it means 30 or 15, it still print the you are not underweight because in our Java the assertion is not enabled yet. So how to enable it? Java minus EA and our class name. So check .java. Make sure it you copy from the top one, so it's not error. So we use it and we enter again. So if 15, so it will become error. So you are underway. It means our um, use the input is not satisfy the expression, so it become error. So how to disable Java minus DA wait dot Java. So it will disable and we put the 50 again and it will disable our assertion. So that's all for our the example of assertion. So I will give to the other tutor to teach you about the interface. Thank you.
All right. Can you guys hear me?
Yes, we can hear you.
Okay, so I will continue for the interface example. So you can see the screen, yeah?
Yes.
Okay. So for the first example, like in the lecture now. So the first interface, interface drawable. In the interface we have two methods. So above the methods we can put some explanation about how to use the methods. So it is more easy for other people that want to use the interface to understand. So when you want to implement the interface, you must make sure that you have all the interface in the drawable must also have in the class you want to implement. So white draw, here you also have white draw. Set color, you have set color. So for example, maybe we add another one in the interface. So maybe what price, integer price. So now we can see that there is an error for the flower class. So how to resolve this? You must make sure that all the interface, method interface must also has in the class. So here we just need to add a big word price. So there is no more error. Okay, next for the second example. Okay, for the next example we have interface 1. So in the interface we also can add a variable that is public, static and final. so that any other class that wants to implement this interface will have the exactly same number. So we have method display. So next we want to implement the interface one. Class test class implement interface one. So remember you must have the methods what display. So for the main method, so we create a new object test class t equal to new test class t.display. This is for to use the class to display the git. And this system out.println a. So the a here comes from the interface a. So when we run, wait, wrong. Oh yes. So when we run, it will display git and 10. So the t display method will display the git and system out.println a. A here comes from the interface equal to 10. So it will print 10. Okay, so next example 3. For the example 3, we want to implement more than one interface. So first interface, we have one method. Second interface, we also have one method. So when we want to implement, just type class demo class implement first interface, comma second interface. So the method also you must have all the methods that you implement from. So public void method, public void other method. Okay, for the main class, let's now the lecture set. So we can use the object class from the object to implement the interface to create a new object. So here first class, first object. So when you print, when you run, yeah, you will print some text, some other text. So for the my first object, the my method will print some text, and the my second object will print some other text. Okay, so I think that's all for the interface example. So that's for me. Thank you.
Okay, thank you, Azhar, for your demonstration. So guys, that's the end of our session for today. If you have any question, you can just type it in the chat box. But if you don't, you may leave. But before you leave, I have a few announcements to make. We have already uploaded our learning materials up to this lecture to our website. So you can just go to our website to fetch the materials. Also, the recorded session for today will be uploaded to YouTube in a few days. So keep in tune. And lastly and finally, don't forget to follow our official social media to get the latest update on Project J. So if you don't have any question, then you may leave. If you do have a question, then you can type it in chat box. We will be more than happy to answer all of your questions. All right, thank you.